We now move on to the last example, example 3. This example will illustrate the usefulness of the formula Sn is equal to n over 2 multiplied by a plus l. The question now asks us to find the number of terms and the summation of the following arithmetic sequence: 6.4, 6.2, and so on, all the way to the last term, negative 10. Since we have been given a finite arithmetic sequence and we know what the last term is, the formula Sn is equal to n over 2 a plus l may be very useful. So what we need to find is Sn and n. So using Sn is equal to n over 2 a plus l, we now get Sn is equal to n over 2 multiplied by 6.4 plus negative 10, since a, the first term of the sequence, is 6.4, and l, the last term of the sequence, is negative 10. Therefore, our Sn is equal to minus 9 over 5 multiplied by n. Let's call this equation 1. We may also need to use the formula Sn is equal to n over 2, 2a plus n minus 1 times d, because we have two unknown variables, namely Sn and n. Therefore, Sn is equal to n over 2 multiplied by 2 times 6.4 plus n minus 1 multiplied by negative 0.2, since a, the first term, is equal to 6.4, and d, the common difference between the arithmetic terms, is negative 0.2. Therefore, Sn is equal to n over 2 multiplied by 64 over 5 minus 1 over 5n plus 1 over 5. Therefore, Sn is equal to minus n squared over 10 plus 13 over 2 times n. Let's call this equation 2. We can now solve these equations simultaneously by substituting 1 into 2. Therefore, negative 9 over 5n is equal to minus n squared over 10 plus 13 over 2n. Rearranging this formula into quadratic form, we now get 0 is equal to minus 1 over 10n squared plus 13 over 2n plus 9 over 5n. We can now factorize this equation such that 0 is equal to n multiplied by minus 1 over 10n plus 83 over 10. This now implies that n is equal to 0. We must of course reject this answer, as we can see that there are more than 0 terms in this sequence, and n could also equal 83. So we know that this arithmetic sequence contains 83 terms. We now substitute n equals 83 into the equation 1. So S83 is equal to minus 9 over 5 times 83, which is equal to minus 747 over 5, which is the summation of the 83 terms in this arithmetic sequence.